This video is going to focus on divergent plate boundaries and how new oceanic lithosphere is created there. We'll see that almost all of the divergent plate boundaries on our planet are found in our oceans instead of continents. But when we have divergent boundaries inside of our oceans, when they separate, new ocean floor is going to be created in the gap that is created as they start separating. So this gap between the two separating plates and the new seafloor is called a spreading center, because as the two plates spread apart, a new center is being created. So we see that the very center of these divergent plate boundaries in our oceans are what are called oceanic ridges. They're going to be a ridge or a really high area along our seafloor, kind of like a linear mountain chain. And the reason this is because there's a lot of heat flow that's coming up as magma fills the gap between these two separating plates. And over time, that magma cools down and solidifies into new igneous rock. But because it's so hot, it's going to help those rocks expand, leading to that ridge look to them. And even when we look at this map, it looks like the ridges are fairly narrow. But in actuality, these mid-ocean ridges are the longest topographic feature on our planet. They cover over 20% of the surface. And that's because they're not only tall, but what this image doesn't really show is exactly how wide they are. Some of them are thousands of miles wide in the middle of our seafloors. But we'll see that in the very middle of our spreading center, there's what's called a rift valley. This is going to be kind of like a really deep canyon right in the middle of the spreading center that we see all the tensional forces where it's being pulled apart in two directions. So we see that seafloor spreading is the process where new seafloor, new lithospheric crust is being created along these mid-ocean ridge systems. While they're spreading, it's not really at a very fast rate. It's about 5 centimeters per year, which is about the same rate that your fingernails grow. So not a whole lot year by year, but if we're looking at it over millions of years, there are pretty substantial differences. So we see that at the very center of our divergent plate boundary, the spreading center, here the lithosphere, the newly created rock, is going to be really hot. But as we get farther away from the rift center, we're going to see that the lithosphere is older, and because it's older, it's had more time to cool off. Because it's cooling off, that lithosphere is getting denser and thinner. So it's going to kind of sink down along the sides. Even though the majority of divergent boundaries on our planet are found in the ocean, we still do have a few that occur over our continents. And when this happens, we call it continental rifting, because the continents are being rifted, they're being broken. So think about having a piece of gum that you've already chewed, and you start stretching it out. As you're applying tensional forces, you're stretching it away into two pieces, you're going to see that the gum in the middle is being stretched thinner and thinner until eventually it's going to break. We see a very similar process with our continental rifting. We're still going to have tensional forces that are stretching a plate into two, and the lithosphere between these two pulling forces is going to thin out, just like the middle of our gum did. But eventually that brittle crust is going to start breaking, just like our gum does when we pull it too far. And the area between these separating continents is going to fill with water, eventually becoming large oceans. So right now we're seeing two major continental rifts. One's happening in Iceland, which you can see in the left-hand image, but probably a more important one is the one that's happening in East Africa, where the Middle East is actually being pulled apart from the African continent every single day.